Hi everyone, I'd like to welcome you back to my YouTube channel. I really am grateful of the views. I really am grateful of the continued marketing and promotion of this YouTube channel. Yeah, we would like for this channel to reach at least 500 subscribers, so that we release more content, reach out to more students. Okay, a lot of students are in need of help, and sometimes they don't really get the help that they really need from their teachers. And so this is the channel where you are going to get help that is very facilitated, made very easy. So in this channel, I'm going to post, upload classworks, upload notes, do videos to facilitate content. Okay, just work the journey with you guys. Okay, so we will be focusing on maths lit, geography, life sciences, and physical sciences. Okay. Um, so I would really appreciate you telling other students, other people about this channel, your teachers, okay, so that they let their students know of the existence of this very um, beneficial channel. Okay, so let's look at question 2. So still going through the paper. So question 2 has a diagram. Okay, so that is question 2.1. Okay, so it has a diagram, and in this diagram, what do we see? Okay, so what we have in this diagram are basically two drainage basins, okay, or two river systems. Okay, now a river system is the main river, okay, and its tributaries. Okay, that is what we call a river system. Okay, so this is a river system, all of this, but the area that is covered by this river system, what do we call it? We call it the drainage basin. Okay, call it the drainage basin. So if you see, once you see a river system that is unique, that is not connected to another unique river system, then that is one drainage basin, or that area on which you have that river system is a drainage basin. Okay, so in this diagram we can clearly see that, okay, we actually have two river systems. Okay, there's one on the right hand side and one on the left hand side. Okay, so so that means that we have two drainage basins. Okay, and we have a key on the top right. Okay, so we have dotted lines which represent the river system boundary. Okay, so we would say that area is a drainage basin. Okay, that is because you have dotted lines around the river system. So that means the area that is demarcated by those dotted lines, that is your drainage basin. Okay, and then you have a water table. Okay, so a water table is represented by solid and dotted lines. Okay, right, so we can actually see that because the water table is the top layer of groundwater. Okay, and of course you usually find it below the surface. So there we have it here in the front. Okay, all right, okay, cool. Let's head on to the questions then. So 2.1.1, so we are supposed to match, of course, the concepts with the letters in the diagram. Okay, so it's that easy. So 2.1.1, the source of the river. Okay, so what goes on your mind? The source of a river, source of a river, source of a river. That has to be where a point where a river begins. Okay, so we know that these rivers actually empty out towards us. Okay, so that means the mouth, because there we have the sea. Okay, so they empty towards us. Okay, so they flow towards us, and so we know that a source has to be on the northern side. Okay, so what do we have here? C is not pointing at a stream, okay, because it has to be a stream. No, so yes, it has to be B, guys. So look at B. You have a river system there, and this river system, you have this stream actually is a stream that is on the northern end, on the upper hand, on the upstream of the river. And of course, you can see that that is where the river actually began. So because it is allocated a letter, that has to be B. Okay, so B, so the source of the river is B. So the answer for 2.1.1 is B. So we're going with B for 2.1.1. Okay, let's head on to 2.1.2. 2.1.2, the water table. Okay, so according to the key, water table should be represented by a solid and dotted lines. Okay, where do we see that solid and dotted lines? Is it E? Or is it G? Okay. Because E is actually situated at a point where the river actually meets the sea, it's quite difficult to say that it's E. Okay, so that could be a mouth actually. So I'll go with G. Okay, so the water table is G. Okay, it points to that that solid and dotted line that was illustrated in the key there. Okay, that we have as the key. Okay, representing the water table. So that's why it's very important to look at the key, guys. Look at everything, look at your diagram, interpret the diagram before you answer the questions. Okay, so 2.1.3, an interfluve. Okay, what is an interfluve? Again, guys, we remind ourselves, an interfluve, that is a high-lying area between two, it's a high-lying area that is between two tributaries. Okay, so what do we see here? Where do we see a high-lying area between two tributaries? Yes, that should be A. Okay, look at A. So A, and as I like, even interpreting this diagram, you can see that, okay, some areas are drawn or colored with a brighter color, white color, that indicates that they are protruding or they are high-lying. Okay, so looking at A, you can see that as well, that okay, A is indeed a high-lying area and is indeed between tributaries, and so I'm going with A for 2.1.3. Right, let me know in the comments, guys, what you think, what you wrote. All right, okay, so let's head on then. 2.1.4, a drainage basin. Okay, so a basin, guys, should be demarcated by that dotted line. Okay, because that's the river system boundary. Okay, so a basin, of course, there's only one letter that corresponds to or that points to that dotted line, and that is C. Okay, so C has to be a drainage basin. Okay, so I'm going with C on this one, just by interpreting the diagram, looking at what the key is telling me. That gives me clues. Okay, so 2.1. We're done with 2.1.4. Let's head on to 2.1.5. 2.1.5, the river mouth. Okay, the mouth, as I already discussed, it has to be E. Okay, because that is where the river empties out to the sea, or this is where the river meets the sea. Okay, so that is the river mouth. So I'm going with E for 2.1.5. Then 2.1.6, the watershed. Okay, so if you watch my TikTok videos, you should know all of these. You should have gotten all of these. A watershed, remember, we said that it is a high-lying area, okay, that actually separates two drainage basins. Okay, and remember, how do you see a drainage basin? A unique drainage basin, you see it by a unique river system. Okay, so you have two unique river systems here, and they have to be separated by okay, it should be like that. They have to be separated by a in this case a watershed. So a watershed has to be a high-lying area that separates those two drainage basins. And I'm looking at this, the watershed has to be H. Okay, so watershed has to be H. It separates those two river systems, and it is high-lying, so it has to be H. So 2.1.6, we're going for H. 2.1.7, a confluence. What is a confluence? That is where two or more river streams meet. Okay, and I can only see one, and that is D. Okay, so at D, you can see that two streams or two tributaries meet at D. So D has to be the confluence. Okay, so D is a confluence. So 2.1.7, we're going with D. Then 2.1.8, process of infiltration. Okay, process of infiltration. What is the process of infiltration? Well, infiltration, we know that this is actually when your water soaks or is absorbed by the soil. So it basically goes underneath the soil, okay, like that. Okay, so this is actually the process, okay, when it is going underneath the soil. So what do we see here? Do we see any arrow? Oh, actually we do have arrows. We have three arrows, right in front, one on the right, one in the middle, and one on the left. But there's only one that is allocated a letter, and that is F. Okay, so the process of infiltration, we have to go with F on this one. Okay, or I would go with F. Okay, so that's question 2.1 for you guys. Okay, that's how I would have done it. Okay, so we head on to question 2.2. So what are they saying? Various options are provided as possible answers to the following questions. Okay, so this is the multiple choice questions. Choose the answer and write only the letter A to D next to the question number. Okay, so we're going from 2.2.1 all the way to 2.2.7. Okay, so right, so let's head on then. So what do we see here? Okay, we have a sketch below and questions that are going to be based on this from 2.2.1 to 2.2.4. Okay, right. Okay, so let's look at this diagram here. Okay, so what do we see? Right. So illustrated here is a river that eventually merges or actually empties out to the sea. Okay, so the sea is on the right hand side, the river is on the left hand side, so that means that the river is actually going towards the right. Okay, and we also see that the river is not straight, it has bends. So this is a meandering river. Okay, it's one of the landforms we learn about here in geomorphology. Okay, so it is a meandering river. Okay, so let's look at 2.2.1. The sketch illustrates a or n dash of a river. Okay, we have four options, A to D. The A option is longitudinal profile. Okay, B, plan view, C, oblique view, and D, cross profile. Okay, so what is it illustrating? So let's start with A. Is it illustrating a longitudinal profile? Okay, so remember, a longitudinal profile is a view of a river from the side. Okay, this is what you would see if you were to look at the longitudinal profile of a river. It's a side view. Okay, I'm sure you do remember this profile where we divide this into upper, middle, and lower course. So this cannot be a longitudinal profile, guys. Okay, this is not what we see. This is not a view that we see here. Okay, let's head on to the next one. B. B is a plan view. Okay, what is a plan view? A plan view is like a blueprint, okay, of a house. For an example, like if you look at the design of a house, maybe someone shows you the blueprint of a house, it will illustrate the top view. It's basically the top view, okay? So it's taken from the top, okay? So if this is the ground, have a camera there, taken from the top like that, okay? So it shows taken directly from the top, okay? And of course, plan view. This is a plan view. It actually shows a view from the top, okay? So let's say top view. Okay, people who are doing, students who are studying maths lit should know this. Of course, and so it's very beneficial that you really know all the types of views that we have. So that's the plan view, and see, and this looks like a plan view. So I will give it a small mark there, okay, just as a possible or correct option. And then C, oblique view. Okay, what is an oblique view, guys? An oblique view is a view that is taken from an angle, okay, from a high angle. So for an example, we'd say that a plan view usually taken like vertically like that, downwards, vertically down, whereas an oblique view would be taken from an angle, okay, like that. Okay, so it would usually cover a larger surface area, so it's usually taken from the side. So see, this is your oblique view, okay, and we don't really see that here. We see a top view really, so that's an oblique view, okay. Yeah, I can't say I'm going with that one. And then the last option, D, a cross profile. Okay, so D is a cross profile. So what is a cross profile? A cross profile, this is a view of a river from one bank to another bank. Okay, so I'm sure you do know this type of profile. So the river water is actually coming towards us or into the page like that. Okay, so that's a cross view, cross profile, and that's not what we see. So I have to go with plan view. Okay, so we're going with B for this one, for 2.2.1. So we're going with B, excuse me. Okay, so 2.2.2 says the fluvial landform of feature shown here in the sketch is A. Okay, is it A, a delta, B, a waterfall, C, a meander, or D, a rapid? Okay, so let's look at our options. So what do we see? We said we only see a meander, guys, here. It cannot be a delta. Okay, remember a delta has a lot of sediment, and yes, I do know that this is you usually find a delta in the lower course, and this is actually the lower course, because as you can see, the sea is right next to the river like that. So but we don't see one. Okay, B, a waterfall. Okay, waterfall, no, we do not see a waterfall. C, a meander. Yes, we actually do see a meander. Remember, meander is a bend. Okay, meander is a bend in a river. Okay, so when a river is has those bends, so that river, we say that it is meandering, it's bending. And then D, a rapid. No, we don't see a rapid, so we have to go with C. Okay, 2.2.2. Hope you guys did go with C as well. So 2.2.2, we're going with C. Next question, 2.2.3. This fluvial landform or feature, okay, which is the answer to question 2.2.2, okay, occurs mainly in the dash course of a river. Okay, so now we are asked about the question, the answer that we have provided for 2.2.2. What is in which course is it mainly found? Okay, So of course that would be the middle course, guys. Okay, it has to be the middle course. I understand that this is a lower course, but they say this fluvial landform or feature occurs mainly, okay. Where do you find it? Mainly, okay. So it's very important that you read the question properly. I would interpret it like that. Okay, maybe this is not based on this diagram that we see. Okay, it's a meandering river. We cannot say it occurs mainly in the lower course. In the lower course, we find deposition, guys. We find dumping of sediments and not erosion. And remember, a meander is caused by erosion, particularly lateral erosion. Okay. And where do you find lateral erosion? There we go, in the middle course. Okay. So I would go with middle on this one. Okay, I would go with A. So for 2.2.3, I'm going with A. Okay, let me know what you guys wrote down. Yeah, you might be correct, but I'm going with that one. 2.2.4, the dominant geomorphological process taking place in the course of the river, which is the answer to question 2.2.3. We said it's the middle course, right? Which dominant geomorphological process or fluvial process that we have in the middle course? Okay. So in the middle course, of course, we know that in the upper course we have vertical erosion. That's why we have V-shaped valleys. Okay. And then because of the increase in the volume of water, tributaries joining the main river, now you start eroding laterally, okay, sideways. You start eroding sideways, and so you widen your channel, and so you get a U-shaped valleys. So here we know that is lateral erosion. Okay, so do we have lateral erosion as an option here? No, we actually don't. We have deposition, erosion, weathering, and grading. So it has to be deposition. I mean erosion. Sorry about that. It has to be erosion. Okay. To be specific, lateral erosion. Okay. So we're going with B. Okay, I'm going with B for 2.2.4. Right. Okay, and then says refer to the sketch below showing river rejuvenation to answer the questions 2.2.5 to 2.2.7. So we're going from 2.2.5 to 2.2.7 using this diagram that we see here. Okay, so what do we see? Again, what do we see? Well, we see a structure that looks like steps. We know that these are terraces. So we have a key showing hard rock, soft rock. Of course, the soft rock is mainly easy to erode. Okay. Okay, fine. This landform, of course, is a result of river rejuvenation. Remember, in river rejuvenation, you're actually giving the river energy. Okay. So what results really is that its erosive power increases. So it's able to erode more. Okay. So it increases its erosive power, and by that it forms. There's three landforms that I know of, okay, that results from river rejuvenation. So you have nick points. Okay, so a nick point, of course, looks like that. Okay, so it's like what you would usually find on an ungraded river. You have terraces. Okay, and you have incised meanders. So those are like very sharp meanders. They have sharp turns, and they are very deep. Okay, they are very, very deep. Okay, due to the continuous erosion that they have undergone. Okay, because the river has been rejuvenating over a long period of time. So these are like the three landforms I know of. Okay, that result from river rejuvenation: nick points, terraces, incised meander. Okay, so all right, so 2.2.5 says the cause for river rejuvenation as shown in the sketch is, okay, a rise in sea level, B, a decreased volume of water, C, a drop in sea level, and D, headward erosion. Okay, let's look at this. Let's go option by option. Okay, so we're saying that A, it's an increase, okay, in sea level. Now, first of all, there's never been a cause of river rejuvenation caused by an increase in sea level. I've never seen that cause, guys. It's actually the opposite. If the sea level drops, then you start to rejuvenate your river. Now it becomes faster. So when your river is rejuvenated, it's either it's faster or its volume of water has increased. Okay, so an increase in sea level doesn't increase the speed or velocity of your river. Okay, so that option, which is option A, no, that is incorrect. B, a decreased volume of water. Okay, B, decreased volume of water. Now, how could you rejuvenate, give energy to a river if your volume of water is decreased? Okay, volume of water, if you have like a smaller volume of water, you cannot increase its erosive power. In order to increase its erosive power, there should be a high volume of water. The river channel should be filled with a lot of water. Now you've increased the erosive power, so we cannot go with B. Okay, decrease the volume cannot rejuvenate a river. C, a drop in the sea level. Okay, now a drop in the sea level qualifies as one of the causes of river rejuvenation. Okay, you drop sea level, now you will have water, your river flowing faster and faster. Okay, so in this case, by being faster, it is being rejuvenated, and so it can erode more. Okay, so C qualifies. And then D, headward erosion. Headward erosion, headward erosion, guys, is a result of river rejuvenation. It's not a cause of river rejuvenation. Okay, so when a river gets rejuvenated, its erosive power increases. Okay, so by that we mean the lateral erosion, your vertical erosion, your headward erosion increase as well. So it's basically a result. It's not a cause, so it does not qualify as a cause. So we're going with C for 2.2.5, a drop in sea level. Okay, so we're going with C. Okay, 2.2.6, the landforms of features visible in the sketch due to the rejuvenation is or are. Okay, so we have 4 Roman figures, 4 options, and we are supposed to choose an option that has a combination of 2. Okay, so in other words, what do we call the landforms in the landforms in the diagram? So looking at the diagram, you can see that it has we said these are terraces. Okay, right, so what options do we have here? So the first one is interlocking spurs. Now, interlocking spurs, I would not go with that option. Okay, we do not have we do not have a result of river rejuvenation as interlocking spurs. Okay, even if you go through your notes, there's not a landform called interlocking spurs that is a result of river rejuvenation. Okay, correct me if I'm wrong. And then your Roman figure 2, a valley within a valley. Okay, now I can vouch for that one because this is how it happens. Okay, you have a valley, single valley like that. You have volume of water, of course, flowing. Now you rejuvenate the river. Okay, give it an inch. Okay, maybe there's more volume of water, and so that means more erosive power, right? And so that means going to increase your erosion. Okay, the vertical erosion also will increase. So this means that you are going to dig here, erode here, dig here, erode, such that you form another valley there. Now you have a valley within another valley. Okay, this is a valley within this valley. Okay, so I'm going to go with that, a valley within a valley. And I'm in figure 3, paired terraces. Yes, I'm going with that as well. Incised meanders, no, incised meanders, of course, meanders that are deep and that have sharp turns. So this can't be incised meanders. So I'm going with Roman figure 2 and 3. Okay, so those two. And so which option corresponds with those? So 2 and 3, that is C. Okay, so 2.2.6, we're going with C, guys. Okay, let's head on. 2.2.7, we have, okay, it looks like we have graphs here, 4 graphs. Okay, so 2.2.7 says the longitudinal profile of the river after rejuvenation would be, okay, so after rejuvenation, so after it has been rejuvenated, okay, what would it look like? Would it look like A, B, is it C or D? Okay, so first of all, let's look at this. So normally, if you have, of course, a balance between erosion and deposition, this is the type of profile that you would form. Okay, it's also called a graded profile. Okay, this is when there is a balance between the speed at which erosion is occurring and the speed at which deposition is occurring. So deposition is occurring at the same speed as erosion. Okay, so then you would form this. Now let's say you have rejuvenation occurring. So when rejuvenation occurs, of course, that means that you're going to increase the amount of erosion because the erosive power increases. Okay, so this means now you're going to have erosion being bigger than deposition. Okay, now that balance changes. Okay, that balance is disrupted. So because you're going to have more erosion, that means you're going to remove more. Okay, so I'm going to remove this material. I'm going to remove this material. I'm going to remove here in the middle course even. So the vertical erosion and the lateral erosion, I'm going to increase that. Okay, the deposition stays low like that. Okay, but I'm going to remove or rather increase erosion. So remember, erosion is the removal of material. So what do I end up with? Okay, because I've removed a lot of material there. Look at this. This is what I end up with. Look at this. Now I no longer have that smooth concave profile because now erosion and deposition are not in balance. There's more erosion, so I'm digging more, I'm removing more, okay, than I am dumping. So as you can see, there's an imbalance, and therefore now you form what are these? Nick points. Okay, you form nick points, guys. Okay, this is what it should look like, guys. It should have this profile. Okay, after rejuvenation. Okay, now our options here, with A, B, C, and D. Okay, so C and B, we eliminate those, okay, because they have smooth profiles. Okay, so let's look at A and D then. So A and D are our possible answers here. So with A, remember we have a height increase on the y-axis and of course the profile on the x-axis. Now the source, looking at A, the source, A suggests that the source has the lowest height and the mouth has the highest height. Okay, is that possible? Is that true? Okay, so that is incorrect, of course. The source, you'd find it, of course, in the upper course, and the mouth you'd find it in the lower course. So we know that the upper course, of course, the gradient is steep, it is the altitude is high, is big, and the mouth, of course, is on lower altitude. So it's actually the opposite. So A is not our option, so we cross it off, and therefore we are left with D. So we are going with D. So D has to be our answer, guys. Okay, so D has the correct height increase and the correct profile as well. So for 2.2.7, I'm going with D. Okay, so there we go. Okay, right. Again, guys, let me know in the comments what you guys think, what you guys wrote, what you might have learned, and what you think I made incorrect there. Okay, so let's head on then to question 2.3. We don't have a lot of time. So question 2.3, refer to the drainage patterns illustrated in the sketches A and B below. Drainage patterns, guys, drainage patterns. Yeah, I love this one. Okay, so A, you have A and you have B. Okay, all right, cool. They say in 2.3.1, identify drainage patterns in the sketches A and B. Okay, so drainage patterns, of course, that's an arrangement of streams. Okay, and in A, what drainage pattern do we have there? Okay, is it trellis? Looks like trellis. It looks like rectangular. Which one is it? And these ones, this is one of the most common misconception among grade 12 students, differentiating between trellis and rectangular drainage pattern. Okay, let's look at the trellis. Okay, how is it different? First of all, what makes them similar? Well, both of them, you have tributaries meeting the main channel or main river at 90 degrees, okay, or right angles. Okay, now what makes them different from each other? Okay, now it's basically the main channel, okay, the main river. What's with the main river? For the trellis, the main river is straight. Okay, and then for the rectangular, the main river has bends, okay, or it meanders, and these bends are 90 degrees, by the way. So if I were to draw a trellis pattern, it would look like this. This is a main river, it is straight like that, and then you have tributaries again meeting at 90 degrees. Okay, there we go, there's your 90 degrees, right? Most importantly, the main channel is straight, guys. Okay, for the rectangular, its main channel has bends, 90-degree bends like that. Okay, there we go, that's the main channel. And then of course you have again tributaries joining it at 90 degrees or right angles, okay, like that. Okay, so of course, what do we see here, guys? Is it the trellis or the rectangular? Okay, what drainage pattern do we have here? Okay, I'm looking at this. Of course, we do see the main river is bold. Okay, it has an arrow. It's the only one that has an arrow, and it has bands, guys. It has bands. Okay, so it has to be the rectangular drainage pattern. So A, we're going with rectangular drainage pattern. Okay, and then for B, B is the most common, guys. You can't have gotten B wrong. So B, of course, is the dendritic. Looks like the branches of a tree. Dendritic pattern. Okay. Let's head on. We are just identifying, that's 2 marks. State the underlying rock structure, and rock type on which the drainage pattern in A developed. Okay. So go back again, remembering our drainage patterns. Okay, so A, right? So A is a rectangular pattern, right? What do we know about A? First of all, its rock structure. Let's talk about its rock type. Okay, A, or rectangular pattern, you'll only find it usually develops on igneous rocks. Okay, that and the rock structure, igneous rocks that have cracks. Okay, let me rather do that with cracks and joints. That's the structure, cracks and joints. Okay, so that's the 2 marks there. Okay, right. For the trellis, of course, is the folded sedimentary rock. So you can talk about that for the trellis, but yeah, that's not the point here. So 2.3.3, let's head on, guys. 2.3.3, explain how the underlying rock structure influenced the drainage pattern in A. The rock structure. Okay, remember the rock structure, we said those are cracks and joints, right? So basically, how did that happen? Okay. River channels developed along the cracks and joints via constant lateral and vertical erosion. Creating the 90-degree bends and intersections we see. Okay, this is what I would have written, guys. Let me know, teachers, would you have given me the full marks? What would you have done? Okay, let me know there.